MECCE is a 6-year partnership project funded by the Social Sciences and Humanities Research Council of Canada. We are led by Professor Marcia McKenzie and hosted by CEPIN at the University of Saskatchewan. MECCE is a collaboration with over 80 partners working to improve understandings of what constitutes quality climate change education and communication, while also addressing the absence of robust cross-national data available for intergovernmental and governmental target setting and progress monitoring. Today, we are very pleased to be joined by Dr. Mitzi Bolton of Monash University and Dr. Arno Scharl of webLyzard Technologies. They will be discussing artificial intelligence, machine learning, web scraping, and knowledge extraction approaches to monitoring the Sustainable Development Goals, as well as considerations for end user application and experiences. These technologies promise to be a powerful data collection mechanism to enable compilation of global data sets, with the potential to support improved monitoring and target setting for climate change education and communication. And their work has implications across MECCE's research, including our development of indicators, as well as our digital research environment, which we are currently developing, and will include a data visualization and analytics platform to aid in government and intergovernmental decision making. Just a few housekeeping items before we start. We are recording the webinar to share with our team members and more broadly. We ask that you please keep your microphones and videos muted to help preserve bandwidth. We do have folks coming in from areas that don't have the fastest internet connections. In terms of how the session will go, we will have our 2 speakers present for about 15 minutes each. We are going to have a reflection following that by MECCE researcher Dr. Chris Peach on the implications for MECCE's work, and then we will move to a Q&A session. We'd like this to be as engaging as possible, but also manageable on Teams. So if you have questions, and we hope you do, please enter them into the chat box and use your hand raise function to speak. And then during the Q&A session, I'll call on you to unmute your mic and turn on your video so we can see you, and then you can ask your question. All right, so I am pleased to introduce our first presenter. Dr. Mitzi Bolton is a research fellow at the Monash Sustainable Development Institute in Australia. Dr. Bolton is an experienced public policy practitioner, and she will be discussing a transdisciplinary project she's working on with colleagues at Monash University. The project is exploring the potential of AI and data science for improving decision-making in the context of complex public problems, such as sustainable development. So I will turn it over to her.
Thanks very much, Nicola. Good morning, afternoon, evening, everyone. Eugene, I particularly like the ninja in your background. He's very entertaining. Now I'll just share my screen. Thanks a lot for coming along. I'm really excited to be here. All right. There we go. So before I get started, and thank you for that lovely introduction, Nicola. Before I get started, there's a custom that we now have in Australia, which is to acknowledge the traditional owners of the land that we're meeting on. And that's a small gesture that we have in place to recognise that the continent was managed or sustainably managed is probably a better way of putting it, by Aboriginal and Torres Strait Islanders for tens of thousands of years prior to British colonisation. So what I'm about to say might seem a little odd to some of you, but it's really important from an Australian perspective. So before I begin, I would really like to acknowledge the traditional custodians of the land that I'm joining you from today, who are the Wurundjeri people of the Kulin Nation. If you've ever been to Melbourne, you will have been standing on Wurundjeri land. And I'd like to pay my respects to their elders past, present and emerging. If anyone has any questions about that, I'm more than happy to talk about it offline if you're interested. So to the topic at hand. So thanks again for the invitation. I'm here to present on a project that is not mine alone. It's part of a big team of people here at Monash. And I guess another caveat is that my background is not in AI. As Nicola said, I'm a public policy practitioner. I was in the Victorian government, which is a subnational government, for about a decade, and in the national Australian government for about 2 years. So that's sort of my background, and my PhD focused on what gets in the way of public decision makers achieving what they set out to, and in particular in achieving sustainable development. So prior to coming onto this project, my background in AI was really set in popular culture and things like Black Mirror. So if you have more technical questions, I'm happy to take them, but I may need to take them on notice and put you in contact with some of the other colleagues on my team. Speaking of which, this is who we are. So we're a transdisciplinary project, as was mentioned, and we're an interdisciplinary research team. So I'm from the Monash Sustainable Development Institute, that blue bubble that you can see there. And I think some of you may know my colleague, Professor Rob Raven, but there's a few of us in that team, and we're working with the Monash Faculty of IT and the Data Futures Institute, who are the ones that understand in much greater detail how the AI works and things like that. And also our colleagues in the Faculty of Arts. And the reason that we're doing this is that we see that AI has great potential to help solve some really complex and difficult problems like achievement of the SDGs. And that was where we started, was in can we use AI to track progress of the SDGs? But we also recognise that building tools alone doesn't mean that they'll be taken up by decision makers. So I'll talk about that in a little bit more detail in a moment. But together we're bringing sort of lots of different kinds of expertise that we hope will mesh really well, so that the tools that we develop are actually of value to people. So when we say that there's sort of complex problems, what do we mean by that? Based on who the audience is in this room or virtual room, I'm sure that you can think of government decisions that, despite best intentions, have resulted in less than optimal outcomes. So I'm going to zoom through these kind of quickly, but again, happy to talk through any of them in more detail. So we've known now for 11 years that we're exceeding planetary boundaries, and our response to that knowledge has been pretty slow, at least in Australia. And most of the time today, I'm going to be speaking about the Australian context. So if you have a different experience elsewhere in the world, I'd love to hear it. But we do know that we've known about planetary boundaries and we haven't really been responding to them. We've had extreme bushfires in both hemispheres. So last summer, we call that Black Summer in Australia, because of the relentless bushfires that scorched a significant part of the country. You can see the smoke plume from the southeast coast of Australia there in January from a NASA satellite. And then on the right, you've got from the west coast of America, a similar thing. We also saw those fires happening in rainforests, which, if you think about what a rainforest is, shouldn't really be able to burn by nature. They're wet. We are also witnessing the Great Barrier Reef bleaching significantly and frequently. And that has economic and social impacts as well as environmental ones. And it's at the hands of global policies, which we can try to influence, but also local ones around agricultural runoffs and things like that. We've also had misfired attempts at economic stimulus. Now, this image of pink bats probably won't mean much to the audience here, but quite controversially, I guess in reflection, following the financial crash in 2008, the federal government here instituted a program to encourage energy efficiency in residential properties. So it was called the Pink Bat program, and people were going to install extra insulation in their properties. And that program wasn't rolled out terribly well, and it resulted in a rush of people that weren't qualified to do the work, and resulted in several people losing their lives and a large number of homes actually catching alight. So really well intentioned, let's increase energy efficiency, let's get economic stimulus happening at a time of recession, but really badly implemented. And then I would be remiss not to mention COVID at the moment. Now, in part, that's luck. We're really lucky that we have a border that we can close. But in part, it's also around government decisions. And there's been, while Australia is really well placed, I come from a jurisdiction where we had a second wave, and it's been quite divisive in terms of how people perceive the government's response and responsibility for that second wave. So when we consider these together, you also want to throw in progress on the SDGs. Now, I'm not going to talk to you about the framework because I understand you all know what it is, but the 2020 report shows that even in high-income countries, we're only on track for 3 of the goals by 2030. And at the Australian level, this is a great paper by Allen et al. At the Australian level, we're on track for about 1/3 of the targets that sit beneath those goals, but we're already on track for about a third of those targets before the SDGs commenced. So I barely scratched the surface here, but what I'm hoping to convey is this great unrealised ambition for optimal public outcomes. So why is that? Why don't public decision makers achieve what they're setting out to? I've argued that it comes down to the complexity of the operating environment and the tools that decision makers have to navigate this. We don't really have time for me to get into this today, but again, more than happy to discuss it later on. But I found that there's 40 factors in the Victorian public decision making. So in this subnational region, there's 40 factors that push and pull people to and from the desired outcomes. And based on the people that I interviewed, I would expect that to be transferable to other jurisdictions. And these factors make policy making a grey science rather than a black and white one. And we know from Morawski and Bozarts, this is just one of their papers, but they have many, that, to quote them, identifying the best option in most situations is not feasible, even in principle. And they go on to say that such decisions require computational resources beyond those available to decision makers. When they say this, they're not talking about the resources provided in terms of staff or having access to computers or good internet. They're talking about our human capacity to solve complex problems. And they show that even for relatively simple tasks like working out which are the best items to put in a backpack given certain parameters, we're not capable of resolving the issue. So if we put that all together, it would seem that decision makers struggle to achieve the desired outcomes because of the complexity of the decision-making environment, which we're not really wired to deal with. And to add another lens to that, we could look at each of those influences in detail, or we could individually, or we could look at it at a systems level, at a holistic level. If you aren't familiar with Donella Meadows' work, I would encourage you to go and have a look at her paper and her posthumous book, where she argues that each system has 12 leverage points, which range in terms of the level of impact that they can have on the system, but the level of difficulty there is in applying them. So 1 being the most difficult to apply, but having the most impact, and 12 being the easiest to apply, but having being least transformational. So when we look at those factors that I just showed you, those 40 things that are influencing decision makers, we find that they all have the ability to operate as a positive or reinforcing feedback loop. So that kind of has led to our hypothesis that, well, maybe if we focus on the next highest order feedback loop, leverage point, that will enable us to overcome some of those barriers to achieving things like sustainable development. If it's reinforcing feedback loops that are preventing decision makers from making the decisions they need to achieve sustainable development, whether it be the principles or the SDGs, perhaps we can go up and one leverage point up and sort of change the way that they're operating. So we're focused on that leverage point 6 around changing the structure of information flows. And that's where, for us, AI comes in. So our recent report by our colleagues, Selwyn et al., found that the first thing most people think of when they hear AI is either a robot or a computer. Hopefully for you, it's the more cheerful WALL-E rather than the scary Terminator. But as noted on screen, AI and machine learning can be so much more than that. We're not arguing that it's a silver bullet, but we do envisage that AI may be able to support decision makers when it comes to collecting, making sense of, and addressing gaps in the available evidence, as well as identifying novel evidence. So one of the things that we've found when we've spoken to decision makers around their understanding of AI is that they think that it's a collection tool, a data collection tool, just brings in lots and lots of information and makes sense of it. That's true, but it's also capable of creating novel evidence, and that's can be really, really important in terms of trying to tip over, as I said, some of these reinforcing feedback loops by providing new information flows. So that's, again, fantastic, but just because there's a lot of promise in AI and there's umpteen papers showing, oh, yeah, it works, doesn't mean that it will necessarily have the desired effect. We can't just assume that it will work. So AI also has biases. Those are the programmers. So it's not necessarily the silver bullet to addressing some heuristics at play. There's obviously concerns about the ethics of AI and overreach of the tool. And we also know in the public policy, political science space that just developing new tools, or if you've even ever worked in the public sector, just developing new tools and going, hey, here's this shiny thing, use it, doesn't mean that those tools will fit the need at hand and be taken up. I think if public decision makers had $1 for every time someone said, here's what you need to solve that problem, they'd probably be retiring on some beautiful tropical island that's well above sea level. So in order to address these concerns and bring it all together, we're running 2 streams of research in parallel, developing the AI tools, but also seeking to understand from the decision makers, what do they really need and want when it comes to data and evidence and solving their complex tasks? What are the complex tasks that they're struggling with? What are their hopes and concerns for how AI might support that? And the reason that we're doing that is so that, as I mentioned at the start, the tools that we develop are actually things that people can take up and find useful at the end. So I'm about to talk about one of the tools in the last few minutes that I have. But before I do that, we started on this journey, as I said at the start, focused on how AI might be able to support achievement or progress of the SDGs. And as we've surveyed and interviewed people, what we found is that many of the public decision makers, and this might be uniquely Australian, I'm not sure, many of the public decision makers sort of were a bit dismissive of the SDGs. They might say, oh yeah, look, I've heard of them, but that's for the environmental sector, or I've heard of them, but that's for developing countries, or I've heard of them and I think they align with what we do, but I don't really look at them in any great detail. And you would know, if you're familiar with the SDGs at all, that simply assuming that they align does not mean that you understand how they work or really mean that you can hope to achieve the targets, because if you've got a goal, you sort of need to know the detail of the goal to be able to achieve it. So that's been quite interesting for us, and we've had to kind of pivot our narrative a little bit to be from being focused on the SDGs to being focused on complex public problems such as sustainable development and the SDGs. And in a way, that means we're being a little bit sneaky. Not in a nasty way, but just in a parents hiding veg in spaghetti kind of way. So where policymakers might talk about their particular policy, so for example, there's an environmental management plan for Port Phillip Bay, which is the major water body that the City of Melbourne and the surrounding metropolitan area sits on. And it mentions the SDGs briefly, but the focus, as I said, of the decision makers is not on the SDGs. And so what we're doing is working with them on the areas that they are wanting to address, in this case, nutrient loading into the bay and how it's affecting marine species, both pest and endemic. But we're also bringing to the table, oh, okay, and did you know that this relates to targets 6, 12 and 14 in terms of improving water quality, improving integrated water management, thinking about the life cycle of wastes and waste generation, and protecting marine species from pollution. And so there's almost an education piece that's coming into this as well for us. So we found that if we started up with the SDGs, people kind of glazed over or didn't think it was relevant to them. But by coming in kind of more from the back end, or as I said, the sneaky vegetables in your kids' spaghetti, it seems to be having a bit more cut through. So this particular project is using Bayesian networks, which is a form of causal probabilistic modelling, to try to identify what interventions ought to be taken in order to achieve the goals that have been set out in this state policy. So we're sort of halfway through that, so I can't tell you what the end result will be yet, but again, happy to touch base with anyone later on. But it's been very interesting to see the real interest from decision makers in how they might be able to use AI to support their work. They don't want to rely solely on the tool. If the tool says we do X, we do X, but they're very keen to understand, okay, if the tool says we do X, how do we then embed that into briefs for ministers and things like that? So I think I might be at time now. I really want to thank you again for having me, and happy to take questions, I think now or in the panel later on, but also feel free to reach out to me at Monash, and happy Lunar New Year to everybody. And I'll hand back to you, Nicola.
Thank you so much, Mitzi. That was really interesting, and I think there are lots of linkages to the work that we are planning to be doing, particularly in Axis 3, as we try to impact on policy decision making, and Axis 2, which has to do with developing indicators. We do have about 4 minutes before we want to turn it over to our next speaker. So if anybody has a question for Mitzi, you can type it in the chat or raise your hand, and we can open the floor up for a brief question.
or I can kick back and relax.
It's Marcia.
I can ask a question if we don't have any others on the table right now. If you could just say a little bit more from your last slide, because I wasn't clear and maybe I missed it, but how you're using AI with the decision makers there. So, and also related to that, when you're saying not just using AI to collect data, but to sort of process the data for decision makers. Could you explain that a bit more, maybe in relation to the example you gave?
Sure. Yeah, no, you're right. I did mix a couple of examples there in one, so it's not you, it's me. So with the last slide, in terms of how the first question, in terms of how we're using AI, it's more of a machine learning process, I guess, Bayesian networks. So what we're doing there is a expert elicitation in terms of we've gathered 7 experts, both in terms of the Bay Area, but also the infrastructure and the assets that lead into it. And we're eliciting from them, well, what are the key variables? What are the key parameters around that? That gives us a causal map, which is, basically what any of us could do without AI. Yay! But then you add to that the data. So we have the experts and the government departments have significant quantities of data, too much data, like more than a PhD, more than a lifetime. So there's several PhDs worth of data there. So we'll be attaching that to the variables that the experts have identified, and then we can run that through a machine learning kind of process to identify what are the relevant interventions to take on a probabilistic reasoning kind of pathway, I guess is the best way of explaining it. So that's the machine learning one. In terms of the second question that you had around not just collecting data that's already there, but also, I guess, generating new data. So the other area that we've been looking into is Earth observations. And so an example of that, and I'm always conscious that there's possibly someone on the line that knows a lot more about Earth observations than me, so apologies if that's the case. But so my very basic understanding of that is that you have your satellites go over, and if you think of a water body, the satellites can pick up things like temperature and color changes and things like that. And if you then bring that back to biology, there's lots of linkages in terms of dissolved oxygen and nutrient loading and things like that. So what we were looking at was, or are looking at, I shouldn't say were, what we're looking at is whether or not you can predict algal blooms from the satellite data before they occur, or before they get to the point where they lead to fish kills. So another couple of summers ago, we had some really significant fish kills that killed millions of fish that were vulnerable species. And ultimately, the natural resource managers went out there and aerated the water and moved some of the fish to other water bodies. But that was after millions of the fish had already died. Now, if you use Earth observations to be collecting this novel data about this is what the water body's doing, it's changing, then those natural resource managers can get out there, do the same actions, but prior to those fish kills. And so we see that as a novel source of data because it's not data that they're collecting at all, other than farmers sort of anecdotal, oh, we're on the river and the fish are dying. So that's I guess, an example of how we're seeing novel data collection occurring.
Thank you.
It's so interesting. I can't wait to hear more about this in our Q&A session. Thank you so much. I think we will turn it over to our second speaker. So Dr. Arno Scharl is the managing partner of webLyzard Technology and professor of information system at Monash University, Vienna. webLyzard is a web intelligence platform that analyzes big data repositories and real-time news and social media streams to visualize emerging trends. The platform is used to support decision-making and is used by webLyzard clients such as the American National Oceanic and Atmospheric Administration and the United Nations Environment Program. Thank you so much, Arno, for joining us today.
Thank you very much for the invite, and hello, everyone. I'm glad about the opportunity to show you a bit of our recent work. And let me just share my screen. And before I actually also want to show you a live demo, because I think some of these technologies are best perceived when you see them in action. I just have prepared a couple of slides to let you know of the background, the motivation, and also the underlying technologies. And I also want to, of course, given the scope of today's seminar, where in our content processing workflow, which you see here, we are employing AI technologies. So just very briefly, it's a semantic system. So the underlying idea is to analyze the public debate, to extract knowledge from the public debate on community platforms, in news media, stakeholder websites, social media platforms. So whatever is available in digital form can be ingested directly from the platforms through APIs. It's pre-processed, and then this is where most of our AI components are being used in the knowledge extraction phase. So we do sentiment analysis, opinion mining, named entity recognition, so to automatically identify persons, organizations that appear in the public debate. We have an evolving knowledge graph, an ontology to have a structured layer of the information. We create labels for all the documents, automated summaries. So there's a lot of processing that goes on every document that we ingest, and that's one of hundreds of millions of documents that are added every year. And then once we have collected and enriched this content with metadata through AI components, it ends up in a visual dashboard, in reports, in indicator data that we can serve traditionally through Excel spreadsheets, but also programmatically through APIs. And we have several main applications. I think the first one, the knowledge hub, the use of the platform as a visual analytics platform, is probably most relevant in the context of today's seminar. Two applications I would briefly mention because they were also already mentioned in the introduction. For example, using our tool as a search engine, as a faceted search, visual search tool to explore content. So on behalf of the NOAA Climate Program Office, we built the search for the US Climate Resilience Toolkit, for which we gathered all the climate. So we crawled and mirrored all the websites of US federal agencies, universities, everything pretty much that is done around climate change that receives federal funds in the US. And we filtered it for climate change relevant information, and then we all integrated it and made it available through the search of NOAA. So that's one typical application of this type of semantic technologies, using search engine to convey, to visualize one's own content resources. So that's information for content owners who want to maximize the impact of their content. The other application, which I think resonates quite well with the question of, how do we extract indicators from all these millions of documents, was a platform that we already built more than 5 years ago, started building on behalf of the United Nations Environment Program. It's, by the way, a live website on unepecoresearch.net. You can access it, so that it's available for free to the public. Having said that, on my last slide, I will also give you my email address. You can also get a registered account which unlocks additional features if you would like to work a bit more with the platform. The underlying idea of this platform was that in order to build the best decision models, to make better decisions, to understand the processes, it's really important to know both sides. Have to know the environmental indicators, which of course the United Nations Environment Program gathers from all the member countries, but you also need to understand the public debate, the stakeholder communication surrounding those indicators, because often, unfortunately, as you're all aware, decisions are made not on science alone, but it's more like who is able to influence the public debate, who had better ways to convey their point. And this is one attempt to create more transparencies, to really see where influences on the public debate are happening. It was already presented at the United Nations Environment Assembly back in 2016, and we have continuously evolved it since. This is how it looks like right now, and this is where I would like to give you a brief live demo of the platform. So this is the live system, so it's all just within a web browser, and I will start with a simple query for example, on biodiversity. So it is a full text search engine. We got now 644 documents that we gathered in the last 2 weeks. We have multiple sources. This is just a small selection now. And this is actually also something, if we think of applying our tools or extending our tools, that's in a way just the tip of the iceberg. So this is now global news and NGO coverage. We have some Twitter content in there, but it completely misses the regional website, which we could easily add. It misses a lot of the social layer, a lot of community platforms. So there's a lot of additional information that could easily be added here. So I'm just activating the NGOs here as well. And then, of course, the numbers change immediately. And the idea behind this platform is on the left side, you see a lot of checkboxes, and whatever you select in these checkboxes triggers a search, and that allows you to drill down in the coverage. It allows you to analyze the coverage from multiple metadata dimensions. So what we do with our AI-based knowledge extraction algorithms, we create the metadata, and this dashboard helps you now to analyze this. So for example, we could just compare news and NGO coverage. So now the news associations would be blue. The documents from NGO coverage is yellow. And you see we have a geographic projection of the results. At TechCloud, it uses color coding now to distinguish that. Or I could classify it by SDG. So we look at biodiversity coverage, and we could compare life on land, climate action, and life below water, for example. So it triggers these search in real time, and now you get the associations, what were English language news media and those organizations associating with the 3 SDGs in the context of biodiversity. And you can easily add now other ones as well, infrastructure, peace and infrastructure. So it's all real time and allows you to explore this coverage. It is possible to create a storyline. So if you would like to understand what were the major drivers of the coverage, what you see lower here, this is similar to what you know from Google News and other aggregators, one top story and a cluster of articles surrounding the same topic, but you also get a visual view of what was dominating the coverage recently. You can do this on much larger time spans, and given that you're interested in indicators that might be maybe even of more interesting than short terms, we can now just pick this and go all the way to early September. And now we have just analyzed 10,000 documents that stem from the sources, and you get also these longer trends. So that's also a potential application, of course, to use these content-based metrics and combine them with existing indicators, either trying to replicate them, which would give you, like sometimes when you have survey-based indicators, you can only do them annually or quarterly, monthly. But if you calibrate the system correctly, this system gives you the real-time capabilities then. We have already various indicators in here: frequency, impact, average sentiment, disagreement with the standard deviation of the sentiment. We can run different moving average, that's the raw data, and we can have a 7-day, 30-day, 60-day average, depending on what type of trends you're looking for. We have also other types of metadata available. We can do positive versus negative versus neutral sentiment. Another area where we use AI-based components. We can look at the geographic aspects. We could look now at the source locations. By the way, today I'm just showing English language content, but the system is cross-lingual, so we can mix and match and combine also different languages among each other. And if I would now be interested in the biodiversity coverage that comes from Australian media, you see this quite nicely in the geographic map. Now I have plotted 2 things. I have plotted all the locations that are mentioned together with biodiversity. So I have here 85 documents on Rio de Janeiro, or I have 97 on South America, or 177 metrics. So you also see these tooltips. Whenever you mouse over a location, you try to see what, or you see immediately what was happening in this location. So of course, because it's from Australian media, most of the locations we find here are in Australia. We can also now visualize where the information comes from. All this comes from Australia, but this becomes more interesting if I now add New Zealand coverage, UK coverage, Canada coverage. Then you get immediately the story. Well, where does information comes from? Which are the locations that are being talked about? And when you zoom into the map, it automatically loads data on a more granular level and gives you a very good overview of where in the world this particular topic is an issue. You can drill down on a sentence level. You can really read how is the public debate unfolding. There is a word tree, and just to show you that this is real time, I can now do this on wildfire. Now I've analyzed 9,300 documents that talk about wildfire. So whatever topic you're interested in, you can take a look at which are the sources that are talking about wildfire since the 1st of September. And this is what I mentioned before. I think this would be an opportunity also to extend the system, because it's really a global system right now, but you could get a lot of insights on a country level if you included a lot of regional sources, a lot of community discussions, public deliberation processes. So all this is currently not included. I've mentioned the named entity recognition, that we automatically extract which were the persons, organizations that were mentioned together with specific topic. That's being shown here. It extracts who was mentioned how many times, what was associated with that person, and there's a lot of additional information available as well, and you can use various visualizations then to show the trends. I'm not sure how I'm doing with time.
You are about 2 minutes over, so
I'm already 2 minutes over. Okay. So yeah, I think then I'll conclude it here. As you can imagine, it was not meant to be a full demonstration of the system's capabilities. It was just meant to give you a bit of an initial idea what can be done with semantic technologies, with faceted search, with these AI-based knowledge extraction technologies. I'm, of course, if some of you are interested to learn more about the platform, can always organize a longer demonstration. Here is my email address as well. So if you would like to get a look into that system, which then gives you the ability to define email alerts, define your own topics and things like that, just send me an email and then can create an account for you. So thank you very much, and I look forward to your questions.
Great, thank you so much, Arno. That was really interesting. Okay, I am going to turn it over to Chris, who is going to do some reflections on the presentations we just saw in relation to MECCE's Project AIMS. Dr. Chris Peach is an assistant professor of computer science education at Stanford University. His research explores how machine learning can improve human learning experiences, and he also uses data visualization techniques in his work. So he will be able to speak on MECCE's access to indicator work, because he is a member of that working group, and hopefully a little bit about impact as well.
Okay, thank you very much. I see some hands up. I don't know if we want to, do we have time to answer those, or do you want me to jump in?
Well, we'll turn it over to questions after you're finished. We'll have about
fantastic.
I
mean, you know, what an honor to be here. I really appreciate it. So as mentioned, I'm Chris. I'm a professor in the AI lab at Stanford University. But like all of us, we care about climate change because we have this incredibly pressing issue on our hands. And it's just a total pleasure to be on this team. So access to what we have on MECCE's project is dataset development methods for monitoring and evaluation of climate change education. And just reflecting on the talks we've heard, I wanted to hit on one sentence that I really appreciate, which is who is learning what and where, and who is controlling the conversation. It's a really interesting challenge that we have ahead of us. How could we possibly monitor climate change education? And on some level, this feels incredibly important. For something this important, you imagine it wouldn't be that hard, especially when you think about the power of artificial intelligence. So I get to sit in this wonderful AI lab where my colleagues are building these incredible futuristic visions, which I think have leaked into our public imagination. You have speech recognition that is beyond human capacity. You have image analysis that can, process images like the human brain does. Even AI algorithms that can produce artwork that looks like Rembrandt. We have terrible things like fake videos being made by artificial intelligence. There's an incredible revolution that's happened. And it's this incredible revolution that seems to have projected these truly powerful tools. But interestingly, if you take these incredibly powerful tools and you apply them to a problem like, can you tell me who is learning about climate change? They seem to disappear in their incredible power. And I wanted to take a moment and reflect on that a little bit, because I think it speaks exactly to what we're trying to do in Access too, which is figuring out what data sets we need. Often when I think about what has driven these incredible leaps forward in artificial intelligence, it's the data. As the first talk mentioned, AI is just as intelligent as the data we give it. And it raises the question, where could we be getting the data that we would need to answer this question? Really, I look at some of my colleagues and I see them applying their work to problems which seem fine, but on some level, how could we turn on the artificial intelligence community to trying to help us solve these incredibly important problems? And possibly we could start by just figuring out what is the important data. If we think about who is controlling the conversation, I think we have a good idea that we have access to news media and their sentiments and what is being projected out through Twitter. And that seems to be an incredibly important start. Maybe the challenge for us to think is, okay, what else do we need? If we want to understand who is controlling the conversation in our modern society, where non-formal news and non-formal education seem to be playing this strange and growing role, what do we need to do in the MECCE project in order to collect the data that could drive the artificial intelligence powers to help us answer these interesting questions? So we're left with a powerful task, a great new tool, and the thing that needs to bring it all together is going to be some fantastic data. What a great project to be part of. Really, total pleasure.
Great, thank you. My imagination is running wild as well. So we've had a couple of questions. Our Access 2 lead, Aaron Benevote, he says he has 1 to 2 comments / questions. So I will call on him now to maybe ask one of those questions, and then we can turn on to that. We have about 15 minutes before we end. So,
can you hear me okay? Yeah?
Yes.
Okay. So, yeah, I'm interested in the biases and the things that your evidence doesn't tell us. And so partly I understood from your presentation that to the extent that you drilled down a little bit further with respect to regional, community, or national kinds of media, that maybe this might minimize or mitigate to some extent the biases. But I wonder if again, if we're interested in both education and communication, we're relying on written documents. Okay, so to the extent that things are being exchanged orally, or that they don't create a kind of artifact that gets picked up in the web, maybe the Twitter feed mitigates a little bit that. But I wonder, I'd like you to speak to the question of biases. And one of the ways that I would ask to also kind of think about this is that if we were to collect information and we were looking at trends over time, or if we had cross-sectional information and we looked at variation across various geographical entities, which kind of information, given the databases that you're using, would you consider to be more valid for some reflection on the quantity or even quality of climate change education?
Okay, that was a very multifaceted question. So,
well, she only gave me one. So,
I'll start with the bias. I think bias is a really interesting question because actually bias you have on several levels. Of course, I mean, you mentioned one of them that of course we, at least as it's currently set up, we monitor online communication. So we are not have no record of communication that's not happening on digital channels unless we get transcripts from others. So if you use speech transcription, Chris mentioned speech to text algorithms where also AI is, a really powerful tool. Of course, then you unlock the spoken word as well. So if you would now run speech to text and everything we're saying, we could actually use that and present you, the analysis. You don't have to query, but you create a sidebar with all the recommendation analysis automatically on the sidebar. So this is one level of bias, the sources that you put in. And of course, there is a decision to be made what you include. But on the other hand, this is actually a strength as well, because by comparing the different sources, and this is actually what I tried to show you, I showed briefly the NGOs versus the news, or between the countries. So it's actually a system to reveal the biases by looking at an issue and see, well, how are the different stakeholder groups? How are the different countries? How are the different cultural systems? What are the different associations people have with this issue? And, maybe which aspects are not mentioned in a particular country for whatever reason, political or otherwise. So I think this is another level of bias, which can very effectively be analyzed with the system. You can also set it up. It's not set up for this right now, but for example, gender bias is something we had recently discussed, which would be a great extension to the tool, because of course we can now, we have the named entity extraction of persons. If we divide this by gender, we could actually use the system to see, well, how are, for example, CEOs, heads of state, based on gender treated differently in the coverage. There are definitely there. The last point of bias is when you dig more into the AI, that's also an ongoing discussion, that some of the language models that you use, so a lot of this NLP opinion mining is based on language models, on very large models of how the human language works. And you feed these models with millions and millions of documents. So if the millions and millions of documents you feed to train the language models, you might introduce some biases as well without knowing that. So yes, so I think bias is important to control for bias, to make sure that your underlying models don't contain any, but then when you apply it, I think there's a lot of potential to actually better understand where bias comes from and maybe who might introduce biases on purpose into the public debate. I think I've only answered the first part of your question. Now you would have to remind me of the second part of your question.
No, I think we should also let someone else ask a question since Nicola's there treating us with an iron hand. No, I asked about trends and spatial variation, and which would create more validity in your mind. If you looked at historical trends over time versus looking at the differences across different geographical entities.
I think it depends on the analytic goals that you have. Geographically, it's quite straightforward, especially when you're dealing with the same language. When you use multiple languages, of course, you have another level of bias in there because you will not have a 100% accurate translation of your concepts into the different target languages. In terms of over time, it depends, especially when you use social media, when you started with your data gathering. Because actually, that's maybe news to some of you. Twitter announced 2 weeks ago that for research purposes, they open up their historic archive for free if you sign up with them. So that is actually now an opportunity because we gathered hundreds of millions of tweets for various projects, including the one I've shown. But we cannot look back usually in the past because that's behind the paywall. But now for research purposes, they open this up and you just have to apply. We're just trying this right now. And then hopefully you can go back for 10 years and get the timeline on that particular topic, which would remove a lot of the artifacts from the gathering process.
Mitzi, I'm wondering if you have anything to say about biases. I know that you mentioned that in your presentation a little bit.
I guess I was more reflecting on the biases of the programmers. I certainly had some questions when I was watching Arno's presentation, not to make it all about Arno. Sorry, Arno. But the different groups that you say you picked, you could scrape from in terms of the news and the NGOs and social media. The thing that was missing there for me was the science and the peer-reviewed literature. And now maybe that's behind paywalls, but you might be able to do abstracts. And so in a way, that's a bias that's being built into it because it's around the social discussion, which I get is part of the goal for what you're trying to do. But it's omitting the sort of, for want of a better word, expert discussion. And so if we're then saying, oh, okay, this is how the world sees an issue, and we're not considering that discussion that's going on, then that's an example of bias that's not being built into how we're conceptualizing our AI and machine learning. So that's perhaps one example of bias that we need to be aware of. And if I tie it back to our own work, our IT guys, they can come up with a model for what they think influences the bay, and they do. When we start to do these expert elicitation sessions, we provide people with a series of variables. Well, that's priming them to only see particular variables. Now, it's open to them to add more variables, and we encourage that. But the process in itself is building in biases as you go along. And so you have to be really alert to that so that you can pull yourself back and be very transparent about where those biases might be coming in, I guess is the point that I was trying to make in my presentation.
Yeah, I completely agree with your observation. And it's actually a long plan for us to include peer-reviewed literature as well from sources, or also like, reports from large international organizations, which would have a lot of value also for those who publish the reports. Because, sometimes you have these monster 500-page PDFs that are, have been researched over years. And then, who is reading the whole 500-page document? If you would actually index these documents and, make them searchable through these semantic technologies across to all the metadata dimension, you could then get everything from reports that mention a particular city or together with biodiversity or from a coastal region. So all this metadata you can get from knowledge graph technology, you could specify the context, and you can make all these very large documents much more accessible for any type of user groups.
And I think you're right. It's not just the accessibility in terms of, oh, it's there. It's the accessibility in terms of almost the cleansing of the data in a way. What you're doing is something that many people have said, oh, is that what you're doing at Monash? No, unfortunately, that's not what we're doing. So I'm really excited about your project, and I'm going to be pointing people to it. But I think it's something that the decision makers that are trying to achieve things like the SDGs, oftentimes they'll use a Google search to try to work out what they should do or what they should put into this ministerial brief. So if you've got a technology like yours that does reflect on a wide array of sources, and you can pick which ones is the community voice and which ones is the expert voice, I think that's going to be really quite transformational in terms of aiding decision makers to then be able to inform those higher up the chain, hey, this is what we need to do, and this is the evidence base for it. Because at the moment, there isn't the time for them to do that as well as they possibly should.
Thank you so much. I feel like we should have made this seminar about an hour and a half, maybe, instead of an hour. We only have about 6 minutes left, and we've had Antia with her hand up for a while, so I'm going to get her to ask her question.
Thanks very much. Yeah, my question is related to the webLyzard. So thanks also again from my side for all the really nice presentations. And I'm wondering, Arno, you said, so you made it clear why this is a technology that is where we can't keep up with in terms of looking through the documents and in terms of counting, tracking, and so on. When it comes to the interpreting part, the sentiments, positive, negative, neutral, I was just wondering in how far is webLyzard something like validated that you compared it to what a person would and how the person would interpret that also in terms of the contexts. Yep. And so is there a validation, and I'm especially interested in that interested in it since I really digged through, we as a team, through thousands of documents, and we had to go to the specific text details because of the context dependency. So therefore, I'm very much interested in the validation part. Thanks so much.
Yeah, there's a lot of evaluation going on for the individual metadata categories, like sentiment, for example, is just one that I've shown, or also human emotions. So if you build an algorithm to detect human emotions automatically or sentiment, then of course you need to measure the quality, and that's done with precision and recall. That's the two measures you usually use for all these information extraction algorithms. So the recall is how many of the actual positive documents did you mark as positive, and the precision is how many times did you get it right. And the art of that is actually to increase both, because there's a trade-off between. If you lower the recall, it's very easy to get high precision. Because if you pick the 10% of most obvious cases, of course, your algorithm is always right. But the higher you want the recall, the harder it is to get to precision. And in these evaluations, yes, so depending on, and is it sentiment, named entity recognition, all these things are being evaluated that way against human annotators. And it's usually between 80, 85%, which state-of-the-art algorithms can have. And if you think that's low, well, at 90%, usually the human annotators start to disagree. So they can't make their mind up if something is positive and negative. So yes, there is a lot of evaluation going on, but this is, very generic measures. But the same thing, of course, could be done if you model a very specific question you have about the coverage, like finding a specific concept or finding a specific attitude among Twitter users, for example. You could also do that. You have a training data set. You run it, you see how well you're doing in a trainer data set, and then once you have determined this precision, you can assume if you run it on the hundreds of millions that it will perform equally well.
Impressive. Okay, 80 to 85%. Thank you.
Okay, we have 2 minutes left in the session, and Marcia has a question, so I will ask for a very brief discussion of that because I'm cognizant of people's time. So take it away.
Sure. Thank you. Thank you all for your presentations. I just wanted to pick up on Chris's point around these are great processes or potential. What would our data be for the MECCE project that could be could put this to use in productive ways? And I just wanted to at least throw the question out there and welcome any comments from anyone that's on, by email or other ways, but on the types of data that we could look at in the project. In particular, we're interested in the potential of this for the communication aspects of what we're looking at there is less data available otherwise. And for example, I saw Lucy Richardson's on from the Climate Communications Hub at Monash, where they've been looking at news media. So that's one you've spoken about, but other ones we've been interested in, say, are, would it be possible, rigorous enough, et cetera, to look at, say, nonprofit organizations and pull off their web pages? What are the different organizations that are doing things around this? So we're looking at components like public participation in climate change, public awareness to access to information around climate change, and things like that are a bit more nebulous. And also we're looking at formal education and higher education. So just to kind of put people's minds to that task of, like, yes, the media sources, but also other types of information that are available digitally that we might be able to access through web scraping that would provide data for potential indicators around the broad area of education and communication on climate change. So I don't know if you have any.
It would also be an extraction task, for example. If you crawl all the university websites, for example, you could automatically detect course information, and then you build automatically a repository of course information, and then you might be able to, the educational systems, different countries, and again, which issues maybe are over or underrepresented in some of them.
Yes.
I must say, I'm quite curious where the students are going themselves. I know many students are turning online. We did the quick project to look at what Google searches brought up, and you can see in the global south, many people are trying to get their climate change questions answered through the internet. I don't know where all the students are going. Maybe it's YouTube, maybe it's Google, but if we can find out where the students are themselves, that also seems relevant. Well,
so just to welcome people to put in the chat or send other ideas you have for potential digital data that we might want to put these technologies and processes to work with. So thank you all.
Excellent. Okay, well, that is time for us today. I want to thank Mitzi, Arno, and Chris for taking the time to speak with us today. And I have a feeling that we're going to be in touch in the future to discuss your very interesting work and pick your brains. We are planning on putting the recording of this webinar up on our YouTube page, so please stay tuned for that. And we look forward to ongoing and interesting discussions with all of you. Thank you so much for coming today.